Hello and welcome to my channel. In this video, we are going to learn about one of the simplest sorting algorithm, that is bubble sort. Bubble sort is a comparison sorting algorithm that repeatedly traverses through the array element by element, compares the adjacent elements and swaps them if they are in the wrong order. With every pass, these steps are repeated until no swaps had to be performed. That means the array is now fully sorted. The reason why this algorithm is named as bubble sort is that in every iteration, elements with greater value than their adjacent elements bubble up or move towards their proper position with each pass. Let's visualize bubble sort algorithm. Here are a few numbers that I would like to sort in ascending order. So as I said, in bubble sort, the adjacent elements are compared. So starting from the 0th index, I'm going to compare 29 and 10. As 29 is greater than 10, so 29 will move towards right side as the numbers are needed in ascending order. So the elements are swapped. Next is the comparison between 29 and 14. 29 is greater than 14, so the numbers are swapped again. Now we compare 29 and 37. 29 greater than 37 condition becomes false, so there is no swapping. And in the end, we compare 37 and 14. As 37 is greater than 14, so 37 will move towards right. And with one complete pass, we can see that the largest number of this array has been placed at the end. But after one pass, we can clearly observe that the array is still not sorted. So we need to start with the 0th index again in order to get our list sorted. So here we compare 10 and 14. 10 greater than 14 condition is false. Next we compare 14 and 29. This condition is also false. 29 greater than 14 condition becomes true and these numbers are swapped. And with second iteration, I have got the second largest number at the second last position in the array. Now again we start with the 0th index where we compare 10 and 14 as there is no swapping done because 10 greater than 14 condition is false, and here also. So we can see that these elements are sorted and no more comparisons are done because the list is already sorted now. Let's see the steps to code bubble sort algorithm. We are going to run a nested loop in order to traverse through the input array using the variables I and j. We need nested loop as with just one loop, we will not be able to sort the complete array because one complete iteration of a loop gives us the largest number of the array and we place it at the end. But with two loops, we will be able to start with the iteration again and we can compare the numbers from the beginning. The ith loop will run till it becomes less than n minus 1, where n is the size of the array, and jth loop will run till it becomes less than n minus I minus 1. This condition is important as we would obviously not like to compare the unsorted elements with the sorted ones. During the traversal process, if we find that the element at jth index is greater than the element at j plus 1th index, then we swap these adjacent elements, else we continue to traverse through the other elements in the array. In order to show the step-by-step execution of this bubble sort algorithm, I am using pythontutor.com, and to show the visualization of the same, I have used this website VisuAlgo. On the left hand side, you can see I have defined a function bubble sort. It accepts two arguments, which is integer array ARR and its size. Next is the I loop, which is the outer loop, which will run till it is less than size minus 1. Here I have defined this variable swapped, which is of bool type. Initially it is false. This I have included in my code in order to provide the optimized solution for bubble sort. Next is the J loop, which will run till it is less than size minus I minus 1. The condition for this loop you will understand when I show it in the visualization part. So let's begin. Initially, we are going to compare the element at 0th index with the element at 0 plus 1 index. That means we are comparing 4 and 2. As 4 is greater than 2, so the elements will be swapped. And the value of the swapped variable changes to true. Value of this variable will be set to true if there is any swapping done during any iteration. Then we move on to the next numbers, and here we are going to compare 4 and 1. As 4 is greater than 1, again these numbers are swapped. and the value of the swap variable continues to be true. Then we move on to the next numbers, which is 4 and 9. As 4 greater than 9 condition becomes false, so there is no swapping. And then we compare 9 and 8. As 9 is greater than 8, the numbers are swapped and the value of the swap variable is again true. With this, with complete iteration of our J loop, we can see that the largest number of this array is placed at the end. When it is out of the loop, it checks for this condition as the value of this swapped variable is true. So here the condition will become if not true. So it will be if false. The false value will not let this if condition work, and therefore it goes back to the ith loop. The I now changes to 1 and the swapped variable changes its value to false. We again begin with the iteration of this jth loop. Here we are going to compare 2 and 1. As 2 is greater than 1, so we are swapping these values. Next, the value of swap variable you can see changes to true from false, and we compare now 2 and 4. As 2 greater than 4 condition is false, so we move to the next elements where we are checking 4 greater than 8. This condition is also false, and now we are not comparing anymore because 9 is already sorted. So J loop ends and this condition again is checked, and we move to the next iteration wherein we are again changing the value of the swap variable. Begin with the first iteration of jth loop. Here we are going to compare 1 and 2. We can see that 1 greater than 2 condition is false, so there is no swapping. In the next iteration, we are comparing 2 and 4. Again, there is no swapping as the elements are in proper order. So 4 becomes the next sorted element, and we are over with our J loop. As you can see that during this run of J loop, the swapped variable did not change its value because this condition was never true. 1 greater than 2 condition became false, 2 greater than 4 condition became false. So this part of if condition never got executed. So swapped variable is still false. And now this condition changes to if not false. That means in this iteration, the values have not been swapped, but we are still left with few iterations of I loop. And before we could reach that point, the array already got sorted. Obviously, there is no need to compare the elements anymore, and to avoid unnecessary execution of these steps, we have placed this condition. So it will be if not false, which will become if true. So now we are going to return and the code gets over. So this becomes the optimized solution for bubble sort algorithm, wherein we are checking if there are no swapping done. That means now the array has already been sorted before we could actually reach the conditions for I. As we have already seen in the visualization that this algorithm does not need any extra space to sort the array elements. So the space complexity for bubble sort is O of 1. Talking about the time complexity, the best case would be when the array is already sorted. That means your requirement is to get the array elements in ascending order and they're already arranged in this order. So the best case time complexity will be O of n. In this case, there is only one pass needed because loop runs through n elements and the array is sorted. So that's why the time complexity is O of n. For average and worst case, the time complexity is O of n square. The worst case would happen when you want to sort in ascending order, but array contains elements in descending order. Now that you have already understood how bubble sort works, let's have a look at different advantages of this algorithm. It is simple to code, as you've already seen. It is easy to understand as compared to other sorting algorithms. It requires very few lines of code and very less additional memory is required in order to sort the elements as per bubble sort algorithm. There are a few disadvantages of this algorithm. When the list becomes big and you have more and more number of elements in the array, then this algorithm becomes inefficient. The average time increases quadratically in bubble sort with the number of elements. So the important question is when to use bubble sort algorithm. When stability is important. The meaning of stability is you can consider any algorithm stable if any two equal elements in the original and the sorted list remain the same, when the array size is small, and when the array elements are nearly sorted. Thank you so much for watching this tutorial. If you like the video, please click the like button. Subscribe to my channel and stay tuned for more videos on sorting algorithms. Till then, keep working with smile.